All right, so this is geometry, semester 2. It's the unit on conics, number 7, and this is the lesson on the ellipse. It's on creatormath.com under the geometry tab. Here are the directions. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Conic shapes, which include the circle, ellipse, hyperbola, and parabola, are produced from what figure shown in the diagram below? Well, we're going for this general understanding of the term, which is a double cone attached end to end. And what that is just a cone this way and a cone this way, and they're here attached at their point. What it allows us to do is cut through these shapes. We cut this way, we cut this way, and this way. And as we cut through those shapes and look at the cross section, we produce different cool shapes in geometry. This one is this guy called the hyperbola, right? And I always spell it hyperbola, so I'm always tempted to say hyperbola, but we spell it hyperbola, we say it hyperbola. This is an ellipse, otherwise in common terms known as an oval, but in geometry we now call it an ellipse. A circle is produced, and a parabola, also spelled parabola, but pronounced parabola, right? So let's go to the first one, and it says if a double cone is cut by a plane is this flat, perfectly flat surface extending in all directions, which is infinitely thin, and we sort of angle it. Notice there's an angle here. If it's this way flat, it's a circle. If it's this way angled, it turns into an ellipse shape. So ellipse is the technical term for what we used to know generally as an oval, and it has unique characteristics. All right, which is the equation of an ellipse? So to help us here, let's go back and just review a little bit. Let's make sure we know how to get to creatormath.weebly.com. That's where all your notes are. Here's what the home page looks like. All your comp book stuff is on the home page. Let's switch over to geometry. Pass by the vocabulary. All this stuff at first is all your vocabulary solutions. And let's get to semester 2, table of contents. This goes in pages 2 through 6 of your composition book. All these things you write in, it's about 2.5, 3 pages long. Here's trig. Here's special right triangles. Here's volume. Here is conditional probability. Here is angles and arcs. And surface area. And finally, conic shapes or conics. Okay. This is the second lesson here on the ellipse. For this publishing, it's pages 129, 130. Make sure you're putting these notes on the right page. Click Notes. It opens a copy of the notes, oftentimes either from the board or from my paperwork, whichever is most current. And mine's not updating. Sometimes, folks, I will have to reload it. Go to the second one again, depending on my internet connection. There we go. And as it clears up, now I can zoom in on it. So first things first, here's an equation of an ellipse that helps me out with this first question. It's x minus h squared, which looks a lot like a circle all of a sudden, but it's got this divided by a squared here, plus y minus k squared, again looking a lot like a circle, divided by b squared, though, is unique. Circle doesn't have that, and it's equal to 1. So anytime you see an equation equal to 1, we're not going to think circle. Yeah, we might, but once we see these items down here, we're going to start to get skeptical, because that's going to be part of the challenge, is trying to figure out which equation we're looking at. Are we looking at which shape from the equation they give us? So H and K is the center, and A and B, A is the x radius, and B is the y radius, all right? And why is A the x radius? Because it's under the term with the x in it. B is the y radius because it's under the term with the y in it. Fair enough? All right, let's see what we've got here. Let's look at this problem then. So here, just to match up with what they already told us in our notes, x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. This is it right here. This is my generic equation for an ellipse. What is the more general term for an ellipse? Oval. I mean, if you're a student just learning an ellipse, it might be easier to go, that's an oval, right? That's good. Now take it up a notch and learn the new term, ellipse. And the ellipse will follow the characteristics of the equation we've mapped out. So what's the center of the following ellipse? Well, it's right here. They tell me with all these guidelines. I just have to figure out where it is. It's 1, 2. 1, comma 2 is this center right here. 1, comma 2. So far, so good. Just, where's a plotted point so far? Nothing difficult yet. All right, let's see what we got here. Which equation matches? Nice. Okay, we're jumping straight up. So it's an ellipse. Okay, we've got a equal to 1. That's good, but that doesn't help us because they're all equal to 1. We're looking for first the center. The center starts here and goes negative 1, 2, 3, 4. So negative 4, comma, and it goes negative 1, 2 on the y. So negative 4, 2. So let's match that up. I'm going to have an x plus 4 and a y plus 2. X plus 4, x plus 4. This is out. This is out. These two are still in because you have an x plus 4. Over here I have a y plus 2 and a y minus 2. This is out. Remember, the original equation has a minus here. The original equation is x minus h squared over a squared plus y minus k squared over b squared equals 1. Notice the minus here and here. So if you have a minus 4 on the h, which is what this is, a minus minus is why it changes to a plus. And because you have a minus 2 here and a minus in the formula, a minus minus turns into a plus. Two negatives equal a positive. If you can't not go to the party, you have to go to the party. All right, I want you to think about that a little bit. If somebody tells you you can't not go, it means you have to go. That's two negatives. So in math and in English, two negatives equal a positive. Which equation matches? Okay, here we go again. So let's go for the center first. Here we are at negative 1, 2, 3, 4. So x is negative 4, comma, we're up 1, 2 on the y. So we're looking for x plus 4. Good, good, out, out. Then there's no negative on the 2, but there is a negative in the formula, so it's going to be y minus 2 here. So we're looking for a y minus 2, so this one's out. It's going to be this one right here equal to 1. Now, let's take a closer look because we didn't look at a and b, right? The formula has this a squared. So if this is a squared equals 81, then a equals 9. That is the x radius. So if we start at the center here and we count the radius, 1, 2, 3, 4, 5, 6, 7, 8, 9. So see this distance here? This is going to be 9. And then this one is the y radius, the radius in the y direction. So 49, the square root of 49 is 7. So this radius here is going to be 1, 2, 3, 4, 5, 6, 7. Okay? This one here is 7. And that's how these pair up. We haven't even needed to use them yet, but we will soon. All right? And that's just to reiterate, because you have x minus h squared over that a squared, right? Plus y minus k squared over b squared. And that's this value here. And those define these radiuses. So by mapping out this whole thing, we can now draw an ellipse that exactly matches this equation. And on that note, we should probably go to here. We're just going to modify our circle equation. All right, let's do x plus 4 and then this whole thing right here, if I can get this right, divided by, there we go, 81. Ready? 81. And then this one is y minus 2. And the whole thing here is divided by 49. And it's equal to 1. Let's get this down to 1. There we go. And let's shrink this a little. And here is the ellipse that we're looking at right now. And notice it matches the one we have here. It's going to be slightly different size because of the scale. The scales being different between the two drawings. But that's how you figure out all these different things. And they just show intercepts here. I was hoping maybe they would show the radii that we're talking about. Let's keep going. All right, which matches? Start with the center. It's out 2, negative 1, 2, 3. So 2, comma, negative 3. So I'm looking for an x minus 2 and a y plus 3. X minus 2, y plus 3. This is out, out, out. Okay. Okay, they're making this quite easy on us, all right? They're not really tricking us or anything. The other issue we're looking for here is the radius, right? If I take this radius in the x direction and I count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This radius is 13. What's 13 squared? It's 169. So I want to see 169 down here. Check. If I look at this one and it's 1, 2, so the radius in this direction is 2, squared is 4. I want to see this one divided by 4. All this matches up for me. The interesting thing is how complicated this looks at first, and then as you start to do them and compare the circle and the ellipse, somehow they're surprisingly straightforward after a while. Okay, so we could even use the x and y radius. Let's say we just counted the radius in the x direction. 1, 2, 3, 4, 5. This is 5. So 25, I'm looking for something over 25. This is out, out, out. They didn't trick us at all in this. And then if I just check it with this radius, which is the y radius, 1, 2, 3, 4, if this is 4, I would square it and get 16. That's 16 right there. So I already know this is the equation of it without even finding the center. All right. All right, let's do it that way again. Let's, because see, I can see all the radiuses. Let's do x radius, count it. 1, 2, 3, 4. 4 squared is 16. Check. Radius in the y direction, 1, 2, 3, 4, 5, 6, 7. 7 squared is 49. I see 49. I've already got the right answer to this. It can't be this. None of those have those same on there, right? But if I want to go back and look at the center again, let's do that again. 1, 2, 3, so this is 3, comma, 1, 2, 3, 4, 5, 3, comma, 5. So I'm looking for x minus 3, y minus 5. X minus 3, y minus 5. Okay, radius, 1, 2, 3, 4, 5. 5 squared is 25. Ding. Radius, 1, 2, 3, 4. 4 squared is 16. Ding. Center is 0, 0. So look, if, this one is kind of interesting. X minus h squared over a squared plus y minus k squared over b squared equals 1. Let's say this is 0 and this is 0. These disappear, right? So now you're left with x squared over a squared plus, am I getting this on the screen? Okay, plus y squared over b squared equals 1. And that's what we've got right here. This term disappears if your center is at the origin. Pretty cool. All right, let's see what they're going to give us now. Nothing. Oh yeah, another origin. So notice there, it's just x squared and y squared. Good, so we have to use the radius, forcing us to do this. 1, 2, 3, 4. 4 squared is 16. Check. This goes up 5, 6, 7. 7 squared is 49. Check. There's no other option here that has those two. I do see a 49, but nope. This one. Remember, for me, students, my option always shows up as A. Yours will show up randomized. So there's a reason mine's showing up at A. It's because I got the solution to it, right? Again, at the origin, so I got to check radii. Let's go in the x. This goes all the way up to 10, 11, 12, 13. 13 squared is 169. 1, 2. 2 squared is 4. Done. Man, when I first look at it, these look daunting. After a while, they just get so much easier. Another one at the origin, all right? This is 5, 6, 7, 8, 9. 9 squared is 81. There's no other 81s. I'm done. Let's see how little work I can do to finish each one, right? Because they gave me 15. Seems like they're giving me too many. Another at the origin. 1, 2, 3. 3 squared is 9. I don't have any other 9s in here. I'm already done. Got to be this one. All right, so make sure you're in the right assignment here. Make sure you're in, it's geometry, semester 2. It's the unit on conics, and it's the second lesson called Ellipse Practice. It's on creatormath.com. Under the geometry tab, you might have to type creatormath.weebly.com into Google to find it. So I hope this helps.